All right, so some of you are still thinking about examples 1 and 2, but remember that in example 1, you still need to answer this question, and then there's a question that's similar in example 2. The yearly wheat yield per acre on a particular farm is normally distributed with a mean of 35 bushels. And those of you who just came in, we did look at a picture of bushels. I'm going to see if I can find it real quick. There it is. All right, so here's bushels of wheat. The wheat is growing around them. These are the bushels of wheat. And so the average in an acre of land, which is an area of land, is 35 bushels and a standard deviation of 8 bushels. We're trying to find the probability that the acre will give us between 19 and 35 bushels. All right, I promise not to call on anybody this time, but I just want to know if you have an answer to that question on your paper. Raise your hand. I see one person has an answer on their paper. Anybody else wrote an answer? I just want to know who has an answer. I'm not going to call on you. I know more than one person has an answer on there. 2 people have an answer. Okay. All right. Raise your hand if you're willing to share your answer. Dion, go ahead.
I got 47.5.
Okay, so Dion says 47.5 is the probability. Anybody get the same thing? I see one nod. I see one hand. Anybody else get that? All right, so Dion, here's the 19 and here's the 35. How did you get your answer?
I did 19.5% plus 34%.
Good. So guys, we're looking at this section here and we're looking at this section here. So the probability is going to be 13.5% plus 34%, and a few of you got 47.5% out of that. That's almost 50% chance that you'll get between 19 and 35 bushels. So pretty fairly likely you have a good chance at getting that. All right, so same information at the beginning. What is the probability that an acre will yield between 27 and 59 bushels? So here's the 27 and here's the 59. If you haven't done this problem yet, I'm going to ask you to try it. We're looking at this section, this one, and this one. And you can use the percentages that you found up here. All right, so from 27 to 59, we're adding this one. Here's 27. So we're adding this one, this one, this one, this one, and here's 59, so that's where it ends. These numbers over here are bigger than 59. Like if you had 60 bushels or 70 bushels, that's over here. So we don't want to add the 0.15%. We want to add 34, 34, 13.5, and 2.35. So the probability 34, 34, 2.35, and 0.15. All right. Anybody want to tell us what they get from that? Bless you. Which one? Oh, what did I forget? Oh, yes. And I added the 0.15. Thank you for correcting me there. All right. 13.5 and 2.35. Did I get it that time, Elisa? Okay. Do you have a total for that? Bless you. 83 point something, right? Yeah. So the whole numbers add up to 83. The decimals will add up to 0.85. So 83.85%. So z-scores are necessary if I ask you a question that is not labeled on the normal distribution. So I'm going to actually go back for a second just to show you what I mean by that. What if instead of asking you, what is the probability that you get between 27 and 59 bushels, I ask you some numbers that are more rounded. What if I said, what is the probability that you get between 30 and 40 bushels? I know 30 is somewhere around here and 40 is somewhere around here, but I don't know exactly those percentages. They are not proportional to the numbers that we have in here because of this curve. So I can't even use a proportion to solve a problem like that. So if I wanted to know the probability I get between 30 and 40 bushels, I need to use something called z-scores. Don't worry, I'm going to tell you all about z-scores. All right. So it's called the standardized value of an observation in a distribution, but generally it just tells you how many standard deviations you are above or below the mean. So for example, I know here that if I got 43 bushels of wheat, then I would be 1 standard deviation above the mean. Remember that this number is the mean? Sorry, this one here is the mean. So if I had 43 bushels, I would be 1 standard deviation above the mean. If I had 19 bushels, I would be 2 standard deviations below the mean. But z-scores are going to tell me, like, what if I have 1.5 standard deviations above the mean, or 3.1 standard deviations below the mean, okay? So if it's not a whole number, we need z-scores. All right, so here's z-scores. This is the formula for z-scores, and those symbols should look really unfamiliar to you because they are not American symbols, they're Greek letters. Z stands for z-score, that's what we're finding out, and x is your number. This is called mu, and it is the mean, and this is sigma, and it is the standard deviation. You don't need to know what the symbols are called. You just need to know it's your number minus the average divided by the standard deviation. That's not a hard formula. You just have to get everything in the right place. All right, so we've got Lynette, and she is 65 inches tall. Is that tall or short or regular? What do you guys think? 65 inches tall. How many feet is that? Anybody know how many feet that is? So I'm hearing tall and I'm hearing short. We should probably figure out how many feet tall she is. There's 12 inches in a foot, right? So how many times does 12 go into 60? Let's see if we can pull that up. 65 inches. I just want to know how tall she is. Like when I do these problems, I don't just like to go through them. I like to understand them. 5 what? 5.4. So I think that's going to be helpful information. I'm just going to convert that also to feet and inches. So I think that you did 65 divided by 12, right? All right, and so you got 5.46666 repeating, right? All right, so I know it's 5 feet. I'm going to subtract out those 5 feet and I get this number. So this is going to describe the inches, and if I multiply it times 12 inches in a foot, so I'm getting 5 inches also. So 5 feet plus 5 inches gives me 65 inches. So she's 5'5". So what do you guys think about 5'5"? Do you think that's taller than average, shorter than average, average for a woman? Average? Okay, let's take a look. All right. Here we are. So this is her height, and since that's her height, that's your number, that's going to be the x. Find her standardized height. Standardized height is the z-score. So find z. If the mean height in her class, so the mean in her class is 67, which means she's a little bit shorter than average in her class. That doesn't mean she's shorter than average overall, just in her class. So in her class, the mean height is 67, and that's the mu, with a standard deviation of 4.9 inches, and that is the sigma there. Okay, now a lot of times people get a negative z-score and they're like, Miss, I think I did it wrong because I got a negative number. A negative z-score just means that your value is below the mean. So if you're shorter than average, you're going to have a negative z-score, no problem. All right, so let's do the z-score. X is 65. and mean is 67, and standard deviation is 4.29. If you do this on your phone calculator, you need to make sure you do 65 minus 67 and then enter and then divide it. I'm going to suggest that you do that on Desmos. Let's see. Just want you to be able to see. There we go. So when I do a big fraction like that, I just put the fraction in first. 65 minus 67 over 4.29. All right, so did I get a positive or a negative z-score? Negative z-score, which means is she above or below the mean? Yeah, negative z-score means she's below the mean. So I'm gonna round this to 2 decimal places. Good morning. Which means it would be negative 0.46, except that there's a 6 after it, so that 6 rounds up to a what? All right, so because we have a 6 after the 6, it's going to round to 7. So I've got negative 0.47. Now that's the z-score. Negative 0.47 is about negative 0.5, right? Close to it. I'm going to keep it at negative 0.47 because you'll see in a minute I need that exact number. However, just in my mind, I'm thinking, okay, she's about half a standard deviation below the mean. Bear with me for 1 second. I'll come right back to this. So if this was my normal curve down here, she would be about here, about half a standard deviation below the mean. Now, remember I said that we cannot use a proportion to find out where she is. It's not going to be the average of the 2 numbers that would be here because, see that? That's not even. But there is a way to find out her percentile. I'm going to tell you about how to find her percentile later because we're going to practice finding z-scores first. I see a few people are still working, that's fine, but if you haven't finished this problem yet, please finish this one. And then feel free to look ahead about Sophia. After we do Sophia's problem, we're going to take a short break so that we can do something on Schoology. So if your computer is not open, please open your computer and go to Schoology. Okay. Sophia scores 660 on the SAT math test. The distribution of SAT scores in the population is roughly symmetric and single peaked, which means it's normal. It means that it can be analyzed the way we're analyzing distributions in this class right now. With a mean of 500 and a standard deviation of 100. So that's Sophia, okay? And then we need to talk about Jim, and I'm gonna use a different color for Jim so that you guys can see we're doing 2 different standard deviations. Jim takes the ACT. So you guys know, like at this school, we offer the SAT, but you can always go to another school and take the ACT. Thank you. Raise your hand if you took the PSAT in the fall. Anybody take the PSAT in the fall when you had to come to school and take it? A couple of you did? Raise your hand if you ever took the SAT. Anybody take the SAT? So the SAT is something that you want to take if you're going to go to college. Not all colleges require it anymore. And then there's another test called ACT. Some people take ACT instead of SAT. Has anybody taken the ACT? Okay. So some people, even though they both measure about the same thing, some people feel like the SAT is better for them and some people feel like the ACT is better for them. So here's Jim. Jim takes the ACT math scores and he scores 26. Now, 26 seems a lot smaller than 660, but they have a different scale. Like, you know how the SOL scale goes from 200 to 800? It doesn't go 0 to 100. So these are different scales. So we're like, I don't really know who did better because I don't understand the scale for these, but z-scores can help us. The ACT scores follow a symmetric single peak distribution with a mean of 18 and a standard deviation of 6. Assuming that both tests measure the same kind of ability, who did better? So you are going to do two different z-scores, one for Sophia and one for Jim. Remember, I underlined Sophia's numbers in pencil and I underlined Jim's numbers in pen. And you just need to figure out what's going to be your x, what's going to be your mean, and what's going to be your standard deviation for each of those. I'm going to pause my video because a couple people just moved in and walked in and I'm going to explain what they missed on the previous slide. All right, so I saw some excellent work out there. I saw people putting 660 for Sophia's score, minus 500 for the mean on the SAT, divided by 100 for the standard deviation on the SAT. All right, and we got 160 over 100, which is 1.6. All right, so did Sophia do above or below average?
Both.
How do you know?
So average was, oh, because it's not negative?
Very good. Okay, so he was starting with the average was, and yes, you can look at, see the average was 500, and so you can see that she did better than average. But he also points out when the z-score is positive, that means you did above average. If it's negative, you did below average. Here's Jim. So Jim scores 26. His mean is 18, and his standard deviation is 6. And so I saw a lot of you got 1.3 repeating. I'm going to round it to 2 decimal places. If I want 2 decimal places here, I can just add a 0. All right, so now, because I wasn't sure before, I wasn't sure who had done better. I can see who did better. Who did better, Sophia or Jim?
Sophia.
Yeah. Sophia did better because she has a higher z-score. So that means that she is farther above the average than Jim. They're both above average. They both did quite well. But Sophia is farther above the average. So Sophia did better. All right, so I'm going to pause here for a minute. What we're going to do is we're going to go into Schoology and do the rule research assignment. So in Schoology, you will find this in Unit 8, Rule Research, right here. So you are going to, actually, can you guys, your name is not Christina and Nat. If you opened it, just delete that, okay? That was from a previous year. Somebody had put that in there. So put your own name or names. Dion,
No.
for you, you're going to put like just Dion, but Nadim is my partner. And Joseph, something similar like that, okay? Just to indicate that it's just you. Sarah, you will write Sarah, Kai. And then the rule should change. So, sorry guys, I thought that I was putting a blank on here. Delete the rule that they put in. And you're gonna put yours. Delete the link that they put in. Ugh, I thought I was putting a blank in. You guys see what I'm doing here? Okay. But actually it was decent for seeing an example. No, you have to do something different. So, look at what I have up here. I'm going to come around and see that your papers are fixed, okay? You need to fix it so it's blank first. The rule that should change is, and you're going to choose the rule. What is your statement number 1 for the survey? So for example, you would have to look up some reasons for your rule and list a website about your rule. And then write a statement number 2 that addresses the reasons for the rule. Write how strongly you agree or disagree with the statement. We need grades to measure whether students learned. So I'm going to come around and help you. Make sure that you're blank to start. All right, so in your packet now, we are on the page that has percentile on it. So remember, we kind of know what percentile you are at when you land on these even standard deviations. So like 43 down here. 43 down here was at the 84th percentile because it was 50% plus 34%. So that was the 84th percentile. But remember, with z-scores, we're analyzing things that don't land exactly on these lines. So we need to find percentiles from the z-scores. And there exists a thing called a z-score table. Now I haven't posted these slides yet, but I'm going to post the slides and you'll be able to click through to find a z-score table. But you can also find a z-score table just by Googling it. So let's look at this. So just Google z-score table. I want you to do this even though you're watching me do this because it's a little tricky to understand at first. So Google the z-score table and you can pick the first one that pops up, but don't let it show you ads. Block it if it tries to show you ads. Okay, so there's something called a z-score table. You can just Google it. See, it wants to show ads. No, that's dumb. Why would I want to see the z-score table ads? All right, so let's think back for a moment about our problem about Lynette's height. All right, remember we said that Lynette was below average in height, negative, and her z-score is negative 0.47. We want to find out what percentile is she at. She's taller than what percent of people? It's negative, so I know it's less than 50%, but I don't know what percent of people. So the z-score table is going to tell me what percent of people. So let's look back and see if we can find negative 0.47 on the z-score table. If you have not found that yet, just Google z-score table. Now I just want to show you the z-score table has 2 pages. The first page is negative and the second page is positive. So since Lynette's was negative, I'm going to be on the negative side. All right, so what I need is negative 0.47 because I went back to Lynette's problem. Here's negative 0.4. Won't let me highlight, but can you see with my cursor what I'm looking at down here? Negative 0.4. Let me see if I can make it just a little bit bigger for you guys. Okay. So down here is negative 0.4, but I need negative 0.47. At the top, this is where the hundredths place is. So the 7 is up here. Okay, look up at my screen for a minute. You see where I'm circling the 7? That's the 7. I'm going down to the tenths place, negative 0.4. That's here. So what you want to do is line them up until you find it. Now I know that this one here is the one that has the 0.07 above it. It's this number here. So that's 0.3192. I'm going to write that on my paper. 0.3192. Remember I went back to Lynette's problem, so that's what I'm looking at. All right, so 0.3192 means Lynette is taller than 31.92% of students. So you see how useful the z-score table was there? The z-score table gave me the percentage. This question didn't ask the percentage, but we're about to do some questions that do ask percentage, so I wanted to show you where that came from. So when you find the z-score, you open a z-score table, and that table will tell you what percent is less than that number. So Lynette is only taller than 31.92% of the students. Remember, she's shorter than average, so she's shorter than the 50th percentile. Let's do the problem down here. So on the driving range, this is not car driving, this is golf driving, okay? A golfer practices her swing with a particular club by hitting many balls, and when she hits her driver, the driver is the name of the golf club. Golf club. The distance the ball travels follows a normal distribution with a mean of 304 yards and a standard deviation of 8 yards. What percent of her drives travel less than 322 yards? So if this is the mean and this is the standard deviation, that means 322 must be the x. All right, it's on a previous slide, so I'm going to write the formula here, x minus mean over standard deviation. Okay. And then let's put the numbers in. Now we're going to find the z-score, and then we're going to use the z-score to find the percentile. Here's her x and her mean and her standard deviation. Okay, who has a question so far? Did I make any mistakes in subtracting or dividing? I think that's right. All right, so this is her z-score. It's not her percentile. We need to use the z-score table. So the z-score table, I hope that you still have it open on a tab, but if you don't have the z-score table open, you can go ahead and open that. You just Google it. Anybody still writing this before I go to the z-score table? Okay, go ahead. Okay, so I'm going to the z-score table to find positive 2.25. So you need to scroll to the second page where the positives are. Here's 2.2. Look at the top to find the 0.05. So 2.25 is a 2.2 over here and a 0.05 up here. If you're looking at your phone, you are not going to get this. Look up at my screen. If I want to find 2.25, I need 2.2 on the side and 0.05 on the top, and you find where they meet up. All right, this is my number, 0.9878. All right, let's go back. What percent does 0.9878 represent? Is that 9%, 98%, 987%? What is it? So you move the decimal just 2 places, right? So 98.78%. So it says, what percent of her drives travel less than 322 yards? 98.78% are less than 322 yards. so when you get that, we're going to turn the page.
How do you get the 9 points?
This one here, it was from the z-score table. Do you want me to show you that again?
I think mine is different.
No, all the z-score tables are the same. Just watch mine for a second, okay? All right, so I needed 2.25. So first of all, what's that? Go to the positive page. Go to page 2. You got it now?
Yeah.
Good. Okay. So we're here, we're gonna do 4B, and I think 4B might be our last one for today. Or, yes, there we are. All right, same golfer. We still have a mean of 304 and a standard deviation of 8, but this time we want to know less than 290 yards. So, first, find the z-score. I want you to work ahead of me here. I'm going to put the formula. You don't need to write the formula every time, but some people forgot it already, so you don't have to flip x minus mean over standard deviation. Okay, so go ahead and find that z-score, and then open your z-score table to find your percent. All right, x is her number 290. Minus the mean, 304, divided by the standard deviation, 8. This time we have a negative standard deviation, a negative z-score. So it looks like negative 14 over 8. And Amr, what did you get when you divided that? That was your final answer. Okay, negative 1.75. Okay, so that was our z-score. And then we're going to go to the z-score table and find negative 1.75 to find what percent is less than 290 yards. Make sure you get that. I'm going to flip over in about 20 seconds. Okay, I need to go back to the negative side, which is the first side. Negative 1.75. So this is negative 1.70. And so that would be 1, 2, 3, 4, 5. So I'm looking at this number, 0.0401, that I saw on a lot of your papers. Okay, and so when I make that a percent, I have 4.01% were less than 290 yards. And I'm going to show you the last answer real quick, just because we have time. We don't need to actually find a z-score for this one, because the last one asks us how many were at least 290. So that's going to be 290 or more. So I know that this percent are less than 290. If I subtract it from 100%, I'm going to find 95.99% were at least.
Can we submit the assignment?
Yeah.
Jason,